Hi everybody and welcome back. We are now going to do a video on compound interest. So the definition here is on the screen. So we are going to start off with this principal. This principal is going to be the initial amount invested. We're going to invest it at some sort of annual rate, and the interest is going to be added m times per year. And then we want to know how much amount we're going to have after a certain period of time. So after a certain amount of compounding periods. Now the book calls this M, but in practice so the book calls this N, but this is really the amount of times you compound per year times the number of years. And this is really the more practical use for in the formula. So notice that my formula is slightly different than in the book because it's just easier to calculate it this way than to figure out a new variable separately. And notice that t is always given in years, so if you're talking about a half a year, you'll want to put a half in, like in our first example here, etc. Note though also that r has to be used in decimal form, even though we're often given it as a percent. So let's look at an example here. So we have 4,000 is invested at 11% compounded weekly. So how much money will be in the account after half a year and then after 10 years? So before we figure out part A and part B, notice that for both problems, P is equal to 4,000. The rate is equal to 0.11, so 11% is a decimal. And then compounded weekly, well, there are 52 weeks in the year, so M is going to be 52. So really, the only difference between part A and part B is what the value of t is. In part A, t is going to be a half, or 0.5. So the amount that's going to be left is going to be 4,000 times 1 plus 0.11 over 52. So we're going to take that 11% interest rate and split it over the 52 weeks. And we're going to raise it to the 52 weeks, but we're only going to go for half a year, so t is going to be a half. And all you do is you just run this through your calculator, so that's what I'm going to do right now. So we have 4,000 times 1 plus 0.11 divided by 52. When you do the exponent, remember to put the entire exponent in a parentheses. So raised to the 52 times 0.5. And I got a syntax error because I put into exponents. So this will be equal to $4,225.91 approximately. Part B, all that changes is now we want to know after 10 years. So we'll have A equals 4,000 times 1 plus 0.11 over 52. But we're going to compound it 52 times a year. But we're going to do this for 10 years. And so we'll just punch this into the computer. So we have 4,000 times 1 plus 0.11 divided by 52. And then again, when you put this in the exponent, make sure you wrap it in parentheses. And we get that we're going to have, after 10 years, $12,002.71. And that's all there is to these compounding interest problems. So next we're going to talk about a type of problem called continuously compounded interest. We'll see you then.